In this video, I'm going to go over iperf 2.014's ability to set the TCP congestion control algorithm via using the -z option. Um, I think it's actually supported in many iperfs. It's just sort of a hidden option most people don't know about. So let's see what these use syscontrol here, and let's grep and see on Cubic and see what kind of options are available. So you can look under the kernel setting on Linux to figure out that these allow congestion controls on this system, which will be my client, are Reno, Cubic, and BBR. And so if I do the same over here, grab Cubic, let's see what I get. And this one only has Reno and Cubic, so we'll run the client on the system that has BBR. So and there's nothing too special here. Let's go ahead and start the server with the enhanced reporting option. Let me clear it just to get a little bit better. And then to set the TCP congestion to BBR, just use -z BBR, and then that'll set it. So it gives you an idea. And what you want to look at is basically the congestion window and the RTT, or if you want to do it, sort of with regression type signals, you can look at net power. But so this gives you the congestion window and the RTT, and that's with BBR. I kind of should do it the other way first with Cubic, so you can see. But you're going to see that with Cubic, it's significantly higher with this particular settings for the window size and whatnot. It's about 1.6 meg versus 600K, and then the RTTs with BBR about 500 microseconds versus with Cubic it's about 1.1 milliseconds. So it looks like Google's BBR is actually doing something useful, which is good because they did a lot of work on that. So it's probably something you can do. But remember, this is a clean network, so you probably want to test this stuff on more congestion networks, Wi-Fi networks. This is a clean 10 gig network, nothing else on this. So you want to, for things like congestion control, you really want to have competing traffic and various scenarios to see how the TCP responds. And just for grins, which I find interesting, and I don't know quite yet, if you actually turn on the trip times option, you'll get Little's Law too. In that one, I don't understand why exactly yet why it's doing what it's doing, but if you'll notice something interesting, even though the RTT, did I do? Yeah, so my RTT is low and my congestion was low, but my if I look here, shrink it a little bit, the bytes in flight are actually pretty high. So I think that's associated with, and the latencies are kind of high. I think those are all associated with, thread scheduling and Linux scheduling and things like that. So these latencies are probably associated more with the writes and reads threads being, scheduled than they are with anything the network stack's doing.